In this problem, we're given that the sine of theta is equal to 3/7, and we know that theta is in the second quadrant, and we're asked to find all of the other trigonometric values. We'd like to find these answers all in exact form, and we can do that by using a couple of identities and relationships and definitions. When we start out with the fact that we know the sine of theta, it makes it pretty easy to find the cosine of theta. In order to do that, we just use that Pythagorean identity relationship that says that the sine squared of theta plus the cosine squared of theta is equal to 1. All right, well, if I know that the sine of theta is 3/7, then I can plug that in, and I can say that 3/7 squared plus the cosine squared of theta is equal to 1. 3/7 squared is 9/49 plus cosine squared of theta equals 1. I can subtract 9/49 from each side, which will give me 40/49 for a fraction. And then to finish, I can take the square root of each side to finish getting the cosine of theta by itself, which is what I'm interested in. Now, remember, when you introduce the square root into a problem, we have both a positive and a negative option. So we have both a positive and negative square root of 40/49. Because we know that theta is in the second quadrant, the cosine of theta, don't forget the theta there, the cosine of theta is going to be equal to the square root of 40/7. We take the square root of both the top and the bottom, but it's going to be negative. The sine is positive in the second quadrant, but the cosine, which is the x-coordinate, is negative in the second quadrant. So negative square root of 40/7 is going to be the value for my cosine. We do want to simplify our radicals whenever possible, and the square root of 40 has the perfect square of 4 in it. So if you think of the square root of 40 as the square root of 4 times the square root of 10, my best way to talk about my answer then is going to be negative 2 square root of 10/7. And this will be the value for my cosine. And again, negative because we're taking the x-coordinate of the second quadrant. All right, so that's the sine. The cosine rather. Finding the cosine of theta is really important because we will need that in order to help us find a whole bunch of the other trigonometric functions that I'm interested in. Let's go ahead while we've got kind of some stuff out here, and let's find the tangent of theta. Now, if you recall, the tangent of theta is equal to, one way we can think of it is as the sine of theta over the cosine of theta. So, using the sine of theta, which we knew from the original problem was 3/7, and the cosine of theta, which we just found to be negative square root of 10/7, we'll be able to find the value of the tangent. Now, unfortunately, what I have here is a complex fraction, which I don't really like, so that's not a good final answer. So, anytime we have a complex fraction, we can change that division into a multiplication problem and flip the bottom fraction over. So I have, instead of 3/7 divided by negative 2 square root of 10/7, I'm going to have 3/7 times negative 7/2 square root of 10. And I see a couple of nice things that'll happen here. My 7s will cancel. That's lovely. And that gives me 3/2 square root of 10, and it's going to be negative because I have a positive times a negative there. However, I don't really like this as a final answer either because it has a radical in the denominator. So to fix that, I'm going to times by square root of 10 over square root of 10, which will give me negative 3 square root of 10 on the top. And on the bottom, it'll give me 2 times just 10, because square root of 10 times square root of 10 is 10. And then I can do that 2 times 10 thing on the bottom. And I end up with, I'm running off the edge of my paper here. Let's make that a little bit clearer for you. So here what I end up with is negative 3 radical 10, or square root of 10, divided by 20. By 20, like that. And that would be the answer for my tangent of theta. So now I have that the sine of theta is equal to 3/7, and I have that the cosine is negative 2 squared of 10 over 7, and I have that the tangent is negative 3 squared of 10 over 20. So just to summarize, I have sine of theta is equal to 3/7 here, and then I'm going to put those values that we just found up here because we're going to need them. The cosine of theta is equal to negative 2 squared of 10 over 7, and the tangent of theta is equal to negative 3 squared of 10 over 20. Now once you have these values, the other three trigonometric functions, the secant, the cosecant, and the cotangent, can all be found by doing reciprocals, essentially, of our primary functions. The secant of theta is the same as 1 over the cosine of theta. So if I look over here, my cosine is negative 2 radical 10 over 7. So my secant of theta can be found by doing 1 over negative 2 squared of 10 over 7. Using the idea that we can times by the flip, I have 1 times negative 7 over 2 radical 10. And I don't really like the radical 10 in the denominator, so I can multiply by radical 10 over radical 10 on the top and the bottom. And I end up with negative 7 radical 10 over 2 times 10, or negative 7 radical 10 over 20. And that would be the value of my secant as I go in. The next one that I'd need to find is the cosecant of theta. And the cosecant, as you recall, is 1 over the sine of theta. Okay, well, I know that the sine of theta is 3/7, because that was given to me in the problem, and it's positive. So my cosecant is 1 over 3/7. Again, 1 divided by this 3/7 is the same as 1 times 7/3. Nothing fancy at all to worry about there, and I get positive 7/3 as my cosecant. The cotangent of theta, there's a couple of ways to think of it, but the cotangent, one way to think of it is just 1 over the tangent. And we found that the tangent is negative 3 squared of 10 over 20. So this is the same thing as 1 times 20 over negative 3 squared of 10. And I don't really like the square root of 10 on the bottom, so I can multiply that on the top and the bottom again. And what I end up with is 20 square root of 10 over negative 3 times 10, which is 30. I can reduce that fraction just a smidge there. 20 over 30 will reduce to 2/3. It was negative, so it's negative 2/3 and radical 10, and the radical 10 is on the top. And so I can have this value here as my cotangent. One nice thing to double check and keep in mind, if the sine is positive, notice that the cosecant is also positive. Because we were in the second quadrant, the cosine was negative, which in this case is going to also make the secant negative. And because one of the sine is positive and the cosine is negative, we will end up with negative values for both the tangent and the cotangent in the second quadrant. Great job.